Perma Pipe received an order from the Williams Company to insulate and jacket over 90 miles of pipe for a new soda ash facility in northwest Colorado. The pipeline consists of two parallel lines along a 44-mile corridor between the mining site and the lower elevation processing site. One line carries the soda ash solution to the processing site. The second carries the recycled hot water back to the mining location. Perma Pipe also performed a thermal and pressure stress analysis of the entire pipeline. Perma Pipe was supplied 60-foot lengths. All pipe was 12-inch diameter, .406 wall, coated with 30 mils of Napguard Gold Fusion Bond epoxy. This coating was chosen for its ability to withstand the continuous operating temperature of 225 degrees Fahrenheit. Perma Pipe transported the coated piping from the laydown area to the insulating and jacketing building. The building was modified to allow the piping to be side-loaded through the wall onto the input racks. Once on the input racks, the piping was visually inspected and the coating was holiday tested at 2500 volts. Before insulating, any damage was repaired by abrading the FBE locally at the area and coating it with an epoxy patch kit. The piping was automatically loaded onto the electrically powered skewed feed conveyor. Friction fit couplings were used to couple the pipes together into a continuous string. The speed of the first inlet conveyor is increased relative to the second to aid in the coupling process. After the coupling process is complete, both conveyors operate at the same speed to feed the pipe into the spray booth. In the spray booth, polyurethane foam is sprayed onto the pipe in one pass to the required thickness of 2 inches. The cure rate is controlled so that the foam is fully risen before application of the polyethylene bonding sheet. The foam has adequate compression strength to support the pipe as it passes along the outfeed conveyor. The foam continues to cure and build strength during the entire process. The speed of the system is approximately 8 feet per minute. The next step in the process is the polyethylene extruder. It is a Cincinnati Millicron 90mm extruder with 300 horsepower drive. The polyethylene material is fed automatically into the feed hopper and color is added automatically through a screw auger. The molten polyethylene is applied to the foam in a thin film at 435 degrees Fahrenheit. Multiple wraps of the molten film result in a seamless polyethylene pipe of the required thickness, in this case 80 mils. A water quench is used to cool the polyethylene. The pipe is fed under a series of water nozzles, and the polyethylene is cooled to 90 degrees Fahrenheit along a distance of 20 to 25 feet. After the polyethylene is sufficiently cooled, the insulation and jacket are cut back from the ends of the two pipes at the coupling. The lead pipe is then accelerated away from the trailing pipe to complete the decoupling process. The completed insulated and jacketed unit continues along the outlet conveyor to the unloading station. The unloading arms automatically transfer the finished unit to the unloading racks. The cutback portion of the insulation and jacket is removed from the end of the pipe. The end surface is cleaned up and will be coated with a moisture barrier. The completed units are carried in pairs by the padded forklift to the finished goods laydown area. All finished piping will be stored in this area for use by the pipeline contractor, who will remove it from the area and transport it to the pipeline trench for installation. The soda ash processing plant in Parachute, Colorado was converted from a closed Unocal shale oil plant. This plant is at the end of the dual pipeline at the lower elevation. The piping is strung along the trench and is ready for installation. The trench on average is about 6 feet wide and 6 feet deep to accommodate both the supply and return pipe. The lower elevation of the pipeline is relatively flat for the first 10 miles before reaching the mountainous region. A bending machine was used to bend the insulated and jacketed pipe. The compressive strength of the foam and the thickness of the jacket were controlled so that the bending machine would not damage them. The maximum angle that could be field bent was 1.5 degrees per foot. These bends were used to follow the contour of the ground and also to make gradual changes in direction. In the machine, each end of the pipe is supported and vertical pistons in the center push down and create the bend. The trench continued alongside an existing road until it reached the mountainous area. A previous pipeline was installed up the side of the mountain and the backfilled area can still be seen. The dual pipeline for this project was installed up the mountainside in the same general area. Supports were attached to the jacket every 10 feet, and the piping was inserted into steel casings. These casings were then pulled up the side of the mountain for the final installation. The piping was mounted on supports alongside the trench to simplify the field joint procedure. After completing the field joints, long sections of pipe could be lowered into the trench. The cutback on the insulation and jacket was wide enough to allow the field weld to be made on the carrier pipe. After welding, an induction heater was used to heat the pipe prior to the application of the fusion bond epoxy. A mold was then used to pour the polyurethane foam into the field joint area. Finally, a yellow polyethylene heat shrinkable sleeve was used to complete the field joint and make it watertight. Perma Pipe utilized an existing warehouse building on the site to set up the foaming and jacketing operation. The customer brought new utility hookups to the building, and Perma Pipe modified the interior to accommodate the machinery. The entire 90 miles of pipe was insulated and jacketed in less than 6 months.